Okay, we're good. Okay, so we'll pick it up right there where we left off the other day. Find the equation of the tangent to the curve, and that's an elliptical curve. 2x squared plus 3x plus y squared plus 4y minus 12 equals 0 at the point 0, -6. Okay, so you know what? I might even call this part A and add a B and a C to this just to make it a little more of a challenge. Okay. If I wanted to try to do this by isolating y, it'd be really hard because notice y pops up in two different terms here, the y squared and the 4y. How would I end up turning this into an equation that looked like y equals? I'd have to go through quite a lot of algebraic gymnastics to make that happen. So I'm going to use my implicit differentiation method. So here's how that works. I am going to take the derivative of this entire equation and the two parts that have y's in them, I have to kind of use my chain rule on. So the derivative of 2x squared is of course 4x. The derivative of 3x is 3. The derivative of y squared is chain rule 2 times y to the 1 times the derivative of y with respect to x. Okay. Plus derivative of 4y is 4 times y to the 0, which is just 1, so I don't need another y, but times the derivative of y with respect to x, and the derivative of 12 is 0, and the derivative of 0 is 0. So that's my new equation. Now, normally when I do chain rule, if I'm doing it the Leibniz way, I would now have to actually put in what this, you know, what is the derivative of y with respect to x. I'd have to substitute that in, or I'd actually have to substitute an expression for x to replace this y. So what is y in terms of x? But I don't know those things. So this remains a variable, and now I treat this like it's a variable. It went from being an operation to a variable. So if I'm going to treat this like a variable, this is, at the end of the day, what I'm looking for. I'm looking for the slope because I want the tangent at this point. So I need to know the slope at that point. So I'm going to isolate the equation for dy dx. So I will leave the two things that have dy dx on one side of the equation, and I'll move the other two parts that don't have dy dx to the other side. All right, now I'm going to use my factoring. I'm going to factor dy dx out of here. And then I'm going to divide both sides of the equation by 2x plus 4. Or sorry, 2y plus 4, not 2x plus 4. And there we go. I now have an equation for the slope everywhere around that ellipse. And I want to know specifically what that is at the point, what was the point again? 0, -6. So I need to know this at the point 0, -6. So I'm going to replace the x with 0. And I'm going to replace the y with -6. And that gives me -3 on top, and -12 plus 4 is -8. So my slope is 3/8. Okay. So I want the equation of the tangent line. Well, I know its slope, so now I just got to find the equation of the line. So we'll pick that up here in just a sec. Okay, we're live again. All right, so we any questions so far? Does everybody get how I got? Let me just zoom out here so you can kind of see the whole thing. Everybody see how I got to the slope? I know the slope at this point is 3/8. And then, okay, I have a slope, and let me make that a bit bigger again. And I have the points 0, -6. So I can easily make an equation. So I'll make the equation y minus negative 6 equals slope times x minus x1, which is 0. So I'll go to standard or general form because that's usually what your textbook gives you. So I'll times everybody by 8 here. And there's my final equation. 3x minus 8y minus 48 equals 0. So that was what they wanted me to get. All right, let's see if we got that right by looking at it in Desmos. So here's the ellipse, and we know that we have the point 0, negative 6, which we could label if you want. There we go. And now I have the equation, what did I say it was? 3x minus 8y minus 48. 3x minus 8y minus 48 equals 0. And looks pretty good. That definitely looks like a tangent. Sometimes you want to zoom in and just to, oops, that wasn't what I was trying to do. I was trying to zoom in. I'll just use the button. Oh, hang on. I'll just use this thing. There we go. Zoom in, zoom in, zoom in. Make sure it's only touching the curve once. If I see that it hits in 2 spots, I know I have some sort of mistake because then that's not a tangent. But it looks pretty good, doesn't it? Definitely got a tangent. Somebody asked me the other day, they said, well, can you actually check to make sure you've got the right slope equation by asking Desmos to do the derivative of this? Because that's what you did last unit when we were doing all the derivatives. And the answer is no. Desmos doesn't quite have the ability to do implicit differentiation on its own. Right? If you remember back to the way I always showed you how to do derivatives with Desmos, we always had to enter it as f of x and then say y equals f prime of x. There are graphing calculators out there, and online free ones, that can do implicit differentiation for you. I think the Wolfram Alpha one can, but they're a little less user-friendly than Desmos, so I kind of like using Desmos. Feel free to shop around, though, if you're just looking for something to kind of help you with homework, or you know, again, you're in a physics class somewhere and you need to find the derivative of something. You're using implicit differentiation and you need to check to see if you've done it right. There are kind of higher calculating things out there than Desmos. But this one's just so easy to use and so visually nice that I tend to kind of always go back to it. So any questions on what I've got happening here? You might want to go to loose leaf. I don't think there was a blank page on the back of this, was there? I was going to maybe do a part B to this, just as a challenge question, just to bring in some grade 11 skills to the table here. What if we asked you? This is the kind of question. This is where you have to kind of now tie your calculus to some problem solving using stuff from old grades. What if I asked you now to find the domain and range of the ellipse, and apparently I don't know how to spell ellipse. And I'll say round your values to, we'll just say, I'll say 2 decimal places. I should probably say if necessary. It'll be pretty clear that it will be necessary in a minute. Okay, so go back to the picture here and start asking yourself, say self, what's my strategy for solving this problem? What is domain and range? Well, domain and range is everything x can be and everything y can be. So what do I need to know here? What are your thoughts? Can you be louder? I need to know when slope is 0. Why does that help me? Right, because when slope is 0 would be exactly when my tangent's horizontal, which would be, so I kind of need to know this y coordinate here, right? And I need to know this y coordinate here. And of course there's symmetry to this thing, so I have a feeling that this y coordinate and this y coordinate are just going to be opposites of each other. All right, now that took care of which part of the question? That took care of range. How would I find domain? Well, notice it's going to be a similar idea, right? It's going to be those 2 points right there. Again, one of them is going to be a negative x, and the other one's going to be a positive x. Although, actually, now that I think about it, you know what? Now that I think about it, they won't necessarily be exact mirror images of each other because this thing is not centered, right? So it's not exactly going to work. But what are you thinking? Okay, what do you thought? Yeah. Yes. I'm going to find these x coordinates, which again aren't going to be mirror images of each other, I now realize, because it's not centered on the x and y axis. But if you didn't hear what he said find where the slope is undefined, right? Because that's where a vertical line is. So, okay, we have a slope, right? Our slope is, let's see, it is negative 4x minus 3 all over 2y plus 4. All right, so first to find the range. To find the range, I would set this thing to 0. And the first calculation is actually really easy, right? I just times both sides of the equation by 2y plus 4, and x pretty much reveals itself right away. I add 3 to both sides, divide both sides by negative 4, and there we have it. But the range is the y coordinate, not the x coordinate. Correct? Think back to the diagram. What did I just figure out? I just figured out what this number and this number is, right? Or actually, yeah, I figured out what that, this is the same x number here. This number and this number are the same, right? So I figured out the x coordinate. I need to know the 2 y coordinates in order to find the range. So how am I going to find that? I'm going to go back to the original equation, and this is where I said your grade 11 skills are going to come in, and this is why I said you're going to need decimals. Anybody kind of see where this is going? What am I going to end up doing to figure out what y is? Anybody see it yet? What's that? Square roots, possibly. It's going to be a quadratic. And it's not going to be factorable, which is why I said decimals. So we're going to put in the x value of negative 3/4, which would be 2 times, okay, 3/4 squared is 9/16, right? And the negative goes away. Plus 3 times negative 3/4, plus y squared plus 4y minus 12 equals 0. And my goal is I have to solve this equation for y. So that's going to make that 9/8. 9/8 minus 9/4 plus y squared plus 4y minus 12 equals 0. All right, I guess the common denominator I need is 8ths. So I have y squared plus 4y. What is 8 times 12? 96? Somebody double check my mental math, but I think it's 96. So 96/8 plus 9/8 minus 18/8. And of course, we already know we're in decimals, so I'm going to cheat and use a calculator here. 96 with a negative on it, plus 9, minus 18, 105/8. Now, am I going to factor this quadratic? Heck no. So what am I thinking already? Remember, remember from grade 11, you have 2 tools in your toolbox that will solve quadratic equations if you can't factor them. What are they? Well, you could complete the square. I don't want to do that. What's the other one? I'm going to use the quadratic formula. Now, if you're using the quadratic formula, do you really want to play with fractions? Me neither. So let's get rid of the fractions. How about we just times the equation by 8, which makes the numbers bigger. True. But I've got a calculator. I don't care how big the numbers are. I just don't feel like punching in fractions. So here we go. Y equals, and remember how the quadratic formula works? Minus b plus or minus the square root of b squared minus 4ac all over 2a. And I have a feeling that thing in the bracket is not a perfect square. That's why I said you can have decimals. Yeah, 4384, is that a perfect square? No, it is not. So there we go. So it's negative 32 plus or minus the square root of, what did I say it was again? 4384. Somebody could punch buttons and make sure I did that right. All over 16. You could simplify that, but I don't think you'd still have an irrational number. This looks like it has a 16 in it. Am I right about that? Is there a 16 in that number? Yes, there is. And yeah, that's it. I think the biggest perfect square you could take out of this number is 16. But let's just go to decimals. So y is two values, and those two values are going to represent my range. Do you get why I know that? So my two values for y are 32 with a negative on it, plus 4384 square rooted, and then divide that by 16. So y is, I'm getting 2.1, I said two decimal places, didn't I? 2.14. And the other answer I'm getting is negative 32 minus that big square root, 4384 square rooted equals, and then divide that by 16, and negative 6.1, again, 4. And that's it. That should be my range. And let's put it in interval notation, from negative 6.14 to 2.14. All right. I didn't have an answer key for this, so I'm actually kind of curious to see if I did it right. Let's go to decimals and see if that's right. Go back to, if you've been zooming in and playing with your graph and you ever want to get it back to normal, you just hit this home button, and then it goes right back to the way it was. Okay, so let's see, what's our maximum? And decimals is nice. They kind of know if you're clicking around there, oh, they probably want the maximum, so I'll just give it to them. So what did I say? 2.13, oh, they have 3 decimal places. That was it. It was 2.138 and 6.138. So there we go. So that took care of domain, or sorry, that took care of range. So now if I'm finding domain, go back to that slope. What was that slope again? It was negative 4x minus 3 over 2y plus 4. And okay, how do I find an undefined slope? Sorry? Exactly. Slope is undefined if 2y plus 4 equals 0. So once again, it just spits out a nice y value for me here. Negative 4, y is equal to negative 2. But I'm going to have to go back to my equation and find out how much it is. So let's see. So what was my equation again? 2x squared plus 3x plus y squared plus 4y minus a 12 equals 0. So I just found out that the y coordinate I'm looking for is the y coordinate of negative 2. And again, look back at the equation. It's like you're finding 2 points, but how do you know the y coordinates are the same? Well, look at them. Notice these 2 points here are the same height, right? So they do have to have both the same y coordinate of negative 2, excuse me, of negative 2. But I need to know the x coordinates. So I know the y coordinates are negative 2. So I'm going to now plug in negative 2 for y. So that's 2x squared plus 3x. Negative 2 all squared is 4. Minus 8 when I plug in negative 2. Minus 12 equals 0. Oh, maybe I'll get lucky in this one, factors. People who hate factoring are going, that ain't luck. I'd rather use quadratics. Okay, fine. If you want to use quadratics, go ahead. Negative 8 minus 12 is negative 20. Negative 20 plus 4 is negative 16. I don't know. First of all, did I do that right? I think so. Now, does it factor? 2 times 16 is 32. Are there two numbers at times to make 32 that are 3 apart? I don't think so. No. Am I wrong about that? I'm thinking. No. Just three people are shaking their heads no. I don't think we can factor that. I think we're stuck with the quadratic formula again. Okay. So x is minus b plus or minus the square root of b squared minus 4ac all over 2a. And if there's people out there going, oh man, I never bothered to memorize my quadratic formula. We would always give it to you. I can't say that a first-year university course would not expect that you know your quadratic formula and not give it to you. So it's something you should work at. You should kind of know your quadratic formula. Okay. So like I said, we can go to decimals. So that's -3 plus or minus. What'll that be? That'll be 9 plus 16 times, no, plus 8 times 16. I don't know what 9 times. I don't know what 8 times 16 is. I should. 64 doubled. 128. Am I right about that? 8 times 16. Yep. So I have 3 plus or minus the square root of 9 plus 128 all over 4. And 128 plus 9 is definitely not a perfect square. So yep, we were right in our conclusion that that thing didn't factor. This is definitely an irrational number. So there's the number. So my domain and range here, if you want exact answers for domain now, my domain is from -3 minus the square root of 137 over 4 to -3 plus the square root of 137 over 4. I am making the assumption that there are no perfect squares in 137 that you could simplify that with, but no, I don't think so. What could there be? No. So there we go. Let's see if that's the right answer. We'll get to decimals and then we'll compare it to Desmos. Because I did say I wanted decimals, right? So 3 negatives minus the square root of 137 divided by 4. So I'm getting -3.68, and 3 negatives plus the square root of 137 over 4 divided by 4, and I'm getting 2.18. Let's see. Is that what we're supposed to get? Well, now they're not being very nice to us here. Unlike the maximum and minimum, which Desmos kind of figures that must be what he's looking for, they're, well, they give me x-intercepts, that's very nice, but I'm going to have to kind of just guesstimate along the curve here. So what did I say it was? -1.3. Okay, oh, I have an idea. You know what I could do? What's that? That's exactly what I was going to do. I could put the y value in there and read the x values. So what was the y value again? Y was -2? Yeah. So I'm going to type in the line y equals -2, and then look for the intersection points. Was that one of them? That's how good my memory is. Yep, there it is, -3.6 whatever. And the other one was 2.176, yep, we got them. So that's the kind of problem solving you can do once you have learned how to do implicit differentiation. Notice again, the actual calculus part was over back when I got this slope, right? Everything else is just kind of applications of your grade 11 skills and just reasoning and problem solving. And if you're wondering where does this kind of math pop up, well, for example, you know, this could be exactly, ellipses are paths of objects in space, right? So you could be figuring out the furthest approach and closest approach of an orbit or something like that. So this kind of math pops up for sure in astrophysics if anybody was going to think of astrophysics as a career. Become the next Neil deGrasse Tyson. Try not to be as much of a jerk when you like review movies and stuff, because I like Neil deGrasse Tyson, but geez, he's kind of a downer sometimes. That's about it. Kind of a shorter lesson today because I just wanted to go through that example. I'll stop the actual video, and then we've got about 10 minutes or so if anybody is stuck on anything from 2.6 yet. Okay, so we'll end the recording.